Welcome to this section of this course. Today I will be speaking about first principle of derivative for trigonometric functions. Okay. Last time I already explained you regarding derivative of first principle for algebraic functions. So today is trigonometric functions. Okay. So we'll be discussing algebraic, trigonometric, inverse trigonometric functions, logarithm functions, exponential functions. Okay, so this is done, but this we are discussing today. Okay, now in order to continue this, we need to have some trigonometric formulas. Okay, so I will explain some brief about some trigonometric formulas. I will derive it with easy format as much as I can. We know that this sine of a plus b is equals to sine of a cos b plus is there plus cos a sine of b. This formula we have. Okay, it meaning if we have two angles, for example 45 or 60 degree or any angle, okay, sine of a plus b is same as sine a cos b plus cos a sine b. Okay, now if I define sine of a minus b is equals to sine a cos b, if it is plus, then you will get plus over here. Okay, if it is minus, you will get minus here, cos of a sine of b. Okay, now we have sine of a plus b, this formula. We have sine a minus b, this formula. Now look at this. If I add and subtract this 1 and 2, what I can get? See, if I add these two angles, for example, let's see question 3. Now if I add these two, this and this will get cancelled. Okay, and see, if I add these two means sine of a plus b plus sine of a minus b. What I'm doing, I'm adding these two. Okay, so on left hand side this we are getting is equals to, on right hand side this plus this become twice. Okay, here we have twice of sine of a cos of b. Okay, here these two gets cancelled. Okay, similarly number 4, if I subtract these two over, if I give minus over here, meaning if I have sine of a plus b minus, what I'm doing, I am giving minus over here. Okay, so minus sine of a minus b is equals to, these two will get cancelled. Okay, here minus plus, what I have twice cos of a sine of b. What I can do is twice sine a cos b is same as this. Okay, or you can say twice cos a sine b is this. Okay, this now we have. Okay, another formula is if we have 5. Similarly, if we have cos of a plus b is, we have cos a cos b with this plus, then minus sine of a sine of b. Cos of a plus b is cos a b minus sine a sine b. Okay, now again if I give minus a minus b is equals to, if it is plus then minus then plus. Okay, here we have cos of a cos of b plus sine of a sine of a. Similarly, now if I add these two, okay, if I this 5 and 6, if I add, then these two will get cancelled and I'll be getting twice over here. Okay, here I will get cos of a plus b plus cos of a minus b is same as here twice, I will get twice cos a cos b, because here this plus this is same as this plus this same. Okay, so I'm giving 1 plus 1 equals to 2. These two gets cancelled because plus and minus here. Okay, similarly 8 if I give minus over here, then if I give minus over here, then minus here, okay? Then these two will get cancelled. Here I'll have minus, it will be twice minus, okay? Let's see. We have cos of A plus B minus cos of A minus B is equals to, these two will get cancelled. Here I have minus twice sine of A sine of B. Be careful here. What we have is, we have this. If 2 sine A cos B, okay, if it is 2 sine A cos B, then you have this, okay, 2 sine A into cos B is same as sine A plus B plus sine A minus B, okay. Now if you have 2 cos A sine B, then you have sine A plus B minus sine A minus B. Now if you have 2 cos A into cos B is this, okay. But over here, if you want to write 2 sine A sine B, then what we can do is, you can send minus this inside, okay. Or this implies, or if and only if you want only if you want to remove 2, okay. So I am multiplying 2 minus on both sides. This will become plus. So I will write first cos of A minus B. Here we'll get minus cos of A plus B is equals to twice sine of A sine of B, okay. Why? What I'm doing is, I am multiplying minus on both sides, okay, so that all these formulas, we have, for example, 1, we have 2, we have 3, or you can say we have 4, okay. All 4 will look one and same, okay. But be careful over here. This is same as this, or this is same as this. You can apply either one, okay. Now let's, by first primitive function, let's choose the simple one, okay. Say one, let's say f of x equals to sine of x. Remember what we have is, by derivative of first principle, we have is limit of this fx plus h. We remember we have this formula, limit of f of x plus h minus f of x upon h, where h tends to 0, okay. This is our main target, okay. Now since f of x is given, okay, sin x, then we need to find what, f of x plus h, and then find limit of all this, okay. Therefore f of x plus, since fx is this, f of x plus h will be what? Instead of x, what we have to do, you have to put x plus h. This same as sine of x plus h. What I'm doing is, instead of x, I'm putting x plus h, okay. Therefore this will be what? F dash x, or you can say dy by dx. You can say f dash x, or df of x, dfx dx. This same as limit of h tends to 0, where h is greater than 0. This, okay, f of x plus h is what? Sine of x plus h minus sine of x upon h, okay. Now here we have two options, okay. Either you can expand this sine a plus b by this formula, okay, or you can do one thing, you can consider this is sine a minus sine b. Where is this? Sine a minus sine b, okay. You can apply that formula also, okay. Or you can expand this sine a plus b. Let's see two ways, okay. First way, this same as limit of h tends to 0. Here we have sine a plus b is what? Sine a cos b plus cos a sine b minus sine x upon h, okay. Now here now h tends to 0, okay. Here h tends to 0, still undefined. Now from these two can you take this sin x common? Here sin A cos B, cos A sin B, sin A cos B, cos A, it should be cos A sin B. Okay. Now from here, from these two, I can take sin x is here, sin x is here. Okay. So I can take common over here. So limit of h tends to 0. If I am taking sin x common, then sin of x. Why I am taking? Because this is free from h. Okay. Here we have cos of h minus 1 upon what? Upon h. Okay. Plus I am separating this. Okay. Now cos x is independent because limits of h tends to 0. Here cos of x into limit of, or you can say here you can keep as it is, sin of h by h. This limit I can separate. Okay. Here if I separate these limits when x tends to 0, sin x by x become a 1. Okay. Now this become 1. Therefore we have only cos x. Okay. Here we have only cos x. Okay. Sin of x when h tends to 0. Okay. Here you can say limit of h tends to 0 is this become what? This become a 0. So this part become, it become when h tends to 0, it becomes 0. 0 into sin x is what? 0. Okay. Here we have cos of x into 1 is we have only cos x. Let's solve derivative of first principle for trigonometric functions by let's have one function as f of x equals to sin x. Previously what I did is another form, so now this is another form. Before this, just remember this formula, some trigonometric formulas. Sin of c plus sin of d, sum and difference formula. You can say sum and difference of trigonometric formula. Okay. Sin c plus sin d is 2 sin of c plus d upon 2 is this angle. Okay, c plus d into cos of c minus d upon 2. 1, 2. If it is minus sin c minus sin d, then 2 cos bring first, cos c plus d upon 2 sin of c minus d upon 2. If it is cos c plus cos d, then write cos of c plus d upon 2 cos of c minus d upon 2. Now 3, 4, cos of c minus cos of d equals to twice. Okay. Now sin of c plus d upon 2 sin of, if I want to write c minus d, then you have to put minus over here. Okay. C minus d upon 2, or if you want to send this minus inside, then sin of d minus c upon 2. Okay, one and same. Just remember another is sin of minus theta is minus sin theta, because sin theta is a odd function. Similarly, cos of minus theta is what? Cos theta. This is what? This is odd function, and this is even function. Okay. Now, most of the all trigonometric formulas, or you can say all the derivatives for first principle, will try to bring either sine or cos. For example, if they have given find first derivative by first principle 10x. Okay, what I have to do is convert sine by cos. If it is any trigonometric functions, can bring into either sine or cos, and then apply this sum and difference formula, and then we'll get the answer. Okay, let's see. Fx is this. Okay, then f of x plus h will be sine of x plus h. Okay, Therefore, by first principle, f dash x equals to limit of h tends to 0, f of x plus h. Okay, here this is our x plus h is sine of x plus h minus f. What is fx? Fx is what? Sine x upon h. Now previous example, what I did is I expand sine of a plus b. Okay, the same answer we are getting. We got f of x sine x is cos x, you got it. Okay, now here what I have to do is I will consider this sine c minus sine d for here. Okay, sine c sine minus sine d, this formula. Okay, now consider x plus h as c and d as x. Okay, by considering this, what I have is limit of h tends to 0. For formula we have twice here. Okay, cos of c plus d, cos of x plus h plus x plus h plus x upon 2 into sine of c minus d. Sine of c is x plus h minus x upon 2 upon h. Here we have minus x and plus x gets cancelled, and here we have when here x plus x is twice x here. Okay, x plus x is twice x. Let's write down another limit of h tends to 0 twice cos of here twice x. Okay, here you can say twice x plus h is, you can say x plus h by 2, or you can keep like this, twice x plus h upon 2 into here what we have is here sine of h by 2, okay, upon h. Okay, now here x can cancel. These two I can bring down here. Instead of 2, what I can do is I can write, instead of h is here 2, I can write like this instead of these 2. Why? Because we have limit of sine of theta upon theta, where theta tends to 0 is 1. Okay, this angle h by 2, this angle h by 2 should be same as this angle, then means theta should be same as this theta, then limit of theta tends to 0, this whole function become a 1. Okay, therefore in order to have h by 2, I already have 2 here, 2 I am bringing down over here, so this become what? This become 1. Okay, this become, when limit h tends to 0, this become 1. Limit h tends to 0, sine of h by 2, this become okay, by this formula this become 1. When h tends to 0, okay, when h tends to 0, here this 0. Okay, here what we have is cos of twice x upon 2 when h tends to 0. Now everything is free from h, 2 gets cancelled, we have cos of x. Okay, this also another formula and another solution for fx equals to sin x. Previous one also one and same. Okay, now fx equals to cos x. Okay, this also we'll find out by first principle. Okay, so since by first principle, what we have to do is, firstly, since f of x is given, so we have to find out f of x plus h. Then f of x plus h minus fx, just find out upon h. Okay, by limit where h tends to 0. Okay, from there we will get answer. Okay, now since fx is this, now f of x plus h equals to what? Will be cos of x plus h. By first principle, what we have is limit of h tends to 0, f of x plus h is what? Cos of x plus h minus cos x upon h. This is what? This is your f dash x. Okay, now what we have is, look at here. Okay, now this is same as cos c minus cos d. Okay, cos c minus cos d, just apply this formula. By applying this formula is equals to limit of h tends to 0, Here minus is there, okay? Here, okay? Here minus 2 sine of c plus d upon 2, okay? Here what we have, c is what? X plus h plus x upon 2 into sine of c minus d. This is our c, this is our d, okay? Let's consider c minus d means x plus h minus x upon 2 upon h, okay? Now here what we have is this minus x and plus x gets cancelled. Now is equals to limit of h tends to 0 minus 2 we have. Here this is same as sine of x plus x is this x and x. Here we have twice x plus h upon 2 into. Similarly, here we have sine of h upon 2, okay? Sine of h upon 2. This h we have, this minus 2, okay? These 2 I can bring over here, okay? Upon 2, these 2, because these 2 will, if you go up, will be here, okay? So I will here, okay? This. Again, this is what? When h tends to 0, limit h tends to 0, sine h by 2 upon h by 2, it become a 1, okay? And when h tends to 0, this becomes 0. Twice x upon 2 is we have x, okay? And here we have is minus sine of x. Therefore, differentiation of cos is what? Sine of x, okay?